Hello. Thank you for everybody for joining today. Good morning, good afternoon, good evening for whatever time zone you're joining from. Today we're going to be talking about some of the new RIEGL innovations and updates from the unmanned laser scanning. We're going to be talking about some of the highlights from Energeo, some of our new sensors and some of our old sensors for those of you who are new. To start, here's the ULS product portfolio. This varies all the way from our Minivux, which is Minivux 1 UAV or Minivux 3 UAV, which are entry level into survey grade LiDAR. These sensors are extremely lightweight, great on small multi-rotor UAVs, and a great way to get into survey grade accurate LiDAR. From there, we jump up to our VUX 1 UAV, still another very lightweight scanner. At 360 field of view, it puts off a higher accuracy and a higher point density than the Minivux series sensor. From here, our evolution is into our next generation of ULS scanning with our VUX 12023. This next generation of scanning features an NFB, so a nadir forward backwards scan pattern. I will talk a little more about that here later in the presentation. From there, we've actually adapted to the VUX 16023. This is again features our next generation of scanning pattern with that NFB pattern and is a longer range version of the VUX 12023 in the sense that it's the same NFB pattern but has a longer range and can be used for both fixed wing UAVs or even low flying aircraft. Then we'll introduce our new VUX 18024. It's our newest scanner, just released this year, with an unparalleled scanning speed of 800 lines per second at nadir. And we have our VQ840GL, which is our bathymetric solution for heavy lift UAVs and helicopters. To start our Minivux SIS configurations, we do have the same APX15 and APX20 product line as before. The APX20, we offer an IMU 90 and an IMU 82. These scanners are very lightweight, with a total weight system, the APX15 being 2 kilograms, 2.3 for the APX20 IMU 90, and 2.5 kilos for the IMU 82, meaning these are great for small multi-rotors and for, again, getting into LiDAR. All these scanners also come available with a DMI interface, meaning they can be used for mobile systems as well. This year, we'd like to announce the new RIEGL RILOC, which stands for Location and Orientation Component. This is RIEGL's entry-level IMU and GNSS solution for the Minivux series. This RILOC is a MEMS-based IMU with a multi-band GNSS of L1, L2, and L5, and a little over 800 hertz sampling rate. This total system weighs in at 1.75 kilograms, which comes in a full quarter of a kilogram lighter than the Minivux with the APX15. Some of the benefits of this new RILOC are it's a fully integrated system by RIEGL with the IMU made by RIEGL, meaning there's no third-party hardware needed and then no third-party software needed for processing the trajectory, meaning you can process the trajectory and process itself. This is going to be perfect for entry-level systems and for small multi-rotor UAVs. To show off what we've done with this RILOC so far, we've gone out and tested a few sites at this point with forestry, power lines, and in quarries in general. We've seen 1.2 to 1.5 centimeters of standard deviation in the vertical, meaning we're getting a very accurate system with this new IMU. Along with this new RILOC and the Minivux, we have our dual use mobile and UAV system in the VMY1. This is an entry-level mobile mapping system that's extremely compact and easy to transport, weighing in at about 20 pounds, making it extremely easy to mount on top of a vehicle. It is a single-headed Minivux head with the option of a Minivux 1 UAV, Minivux 3 UAV, or Minivux HA sensor. The camera options are very flexible with the same offerings as a VMQ 1HA and a VMY2. These offerings are, for example, a Ladybug camera. With this, it's still a very flexible IMU options with both the planning-based options and the new RILOC. With this scanner being a multi-purpose system, The only thing you will need to do to switch from a mobile system to a UAV system is about a 10-minute process to take the cover and the minivux out of the VMY1, then mount it onto the bottom of a UAV for all your aerial scanning needs. As we evolve into our higher accurate systems, we come to the VUX-1 UAV 22 and VUX-1 LR 22. This small and compact scanner offers online waveform processing with a full field of view of 360 degrees. The VUX-1 UAV 22 and the VUX-1 LR 22 respectively have a 1.2 megahertz and 1.5 megahertz measurement rate, meaning you'll be able to produce extremely accurate and extremely dense point clouds from here. With the upgraded lower minimum range, you can even use it on mobile systems as well. This lightweight system comes in at 3.5 kilos and supports up to 4 cameras. With these upgrades, you still get a very high performance and survey grade accurate scanner, improved efficiency and ability, and the ability to use this scanner for mobile systems, UAV systems, or even airborne systems. Coming to our next generation of scanning pattern with our VUX 120-23 edition. This scanner features our nadir forward-backward scanning pattern, which I'll explain more here in a couple slides, at 100-degree field of view, extremely high measurement rate of 2.4 megahertz, and will capture up to 32 targets per pulse. With this large number of targets being able to be captured off one pulse, it's extremely easy to punch through vegetation for any forestry or agricultural needs. Scanner is extremely light, being 2.3 kilos, and does support up to 2 cameras. With the new performance of the forward nadir backwards, it makes it easier to be able to pick up the vertical facades or punch through tree lines for forestry. Extending our next generation of scanning pattern is our VUX 160-23 edition, with still the 100-degree field of view, up to 2.4 megahertz and 32 targets on a pulse. This again is a very lightweight system, being able to be used on both UAVs and for aircraft. Does support up to 5 cameras, which is an upgrade from the VUX 120 if you would need those extra cameras for any sort of airborne usage. It is a very versatile, like I said, being able to be used on a UAV or an airborne system. It's extremely high point density, which makes it great for any sort of corridor mapping applications, forestry, and with this new nadir forward backward scanning and up to 400 lines per second, capturing data has become extremely simple. To explain our new NFB scanning pattern of the VUX 120-23 and the VUX 160-23, here's a quick animation to be able to better show how it may work. As with most traditional scanners, it does have a nadir pattern that it does scan at. All these patterns are rotating, with nadir being your first pattern it shoots out. This allows you to pick up the top of things. Extremely easy. However, there are angles like the side of buildings and the side of poles that you'd not be able to pick up unless you flow to the side of these. Next in the pattern is the forward 10 degrees pattern. This allows you to pick up vertical facades such as the side of buildings or the side of power poles with ease without having to fly offset from the building or power pole, and gives you a different angle to scan through vegetation. The final scan pattern in here is the backwards or the negative 10 degree pattern, which allows you to pick up the backside of objects that you wouldn't normally be able to pick up, such as the backside of building facades, backside of power poles, or again, angles and sides of trees that you would normally not be able to pick up. With this rotating pattern of nadir forward and backwards, you're able to create a very dense and complete point cloud to eliminate as many shadows or missing data as possible. This year, we'd like to announce our new VUX 180-24. This scanner does look very similar to the VUX 160-23, as it is the same form factor, actually. The main differences with the scanner are, instead of 100-degree field of view, you're looking at 75-degree field of view, still up to 2.4 megahertz of measurement rate, up to 32 targets per pulse. It is slightly heavier, being 2.7 kilograms, of course, with the main difference being the VUX 180-24 is capable up to 800 lines per second versus 400 lines per second. This makes it extremely valuable for lightweight UAV operations and airborne operations, and it's perfectly suited for fast-flying fixed-wing UAVs to create high-density maps in corridors, forestry, or anything you would need to fly over very quickly. VUX 180-24 and the VUX 160-23 being the same form factor, we do offer the same IMUs with both, with a fully integrated AP Plus board inside. With the AP Plus board being integrated inside the scanner, this eliminates the need for a board stack outside of the scanner, eliminating close to 1 kilogram of weight. This means the total weight of these systems respectively come out to 3.2 kilograms and 3.15 kilograms for fully integrated systems, with the offering of a Planix AP Plus 50 or an AP Plus 30 for either of the scanners. With this chart, we can see the VUX 180 does fall in between the VUX 160-23 and the VUX 120-23 in terms of range performance. Comparing the maximum flight altitudes of these three scanners, it does have a slightly larger maximum flight altitude compared to the VUX 160. For the sensor comparisons, the VUX 120-23, the VUX 160-23, and the VUX 180-24 all have a similar 2.4 megahertz of PRR and 2 million points per second, similar accuracies with 10 millimeters and 5 millimeters of precision. The main differences you'll see here are the FOV being 75 degrees for the VUX 180-24. However, with that, as stated, it is a 800 line per second scanner versus 400. While you are decreasing the field of view, you are getting double the line speed, giving an extremely dense point cloud that you can scan it very quickly. With all of our VUX 1 series, we do offer an open platform configuration that allows for different mounting. With the RGB cameras, we have the Sony a6000, the a7R3, the a7R4, and coming soon is actually the industrial grade Sony ILX LR1. This industrial camera will end up shaving off a little under a kilogram of weight, allowing you to fly even farther with your UAV than previously before. We also do offer multispectral cameras, and with the FLIR Tattoo, a thermal camera. This mounting platform allows for different scanning angles with these cameras, allowing for nadir and even oblique angles, weight and balance options, and available, we also have a shock absorbing plate. For collection of the data, we use RIEGL embedded, and we have some new updates with our web interface. This web interface provides status information on the initialized, executing, working logging of the scanner, allows you to view number of project records, images, and file sizes to make sure you're not filling up your flash drive or your SD card too fast. And with this web interface, it allows you to change and apply your camera settings on the fly with predefined, which is predefined by RIEGL Embedded Desktop. The outlook on here is our Mavlink integration, which are going to show status messages in the flight planning software with the remote controller. And it's going to show a 2D visualization in the web browser, allowing you to link this to your controller to see what your LiDAR is seeing as you're flying along. An overview of our fully automated UAV-based workflow. First is planning. Planning is done in RIEParameter, where the laser and camera configuration will be set up in the RIEGL Embedded Desktop. The data collection will then be performed automatically or remote control depending on your scanner. With your pre-flight checks, when you're out in the field, the Wi-Fi is going to be automatically turned on, and the configuration can once again be checked through the web interface. The scanner will then automatically start scanning or logging depending on your settings and your scanner. Upon takeoff, the Wi-Fi will automatically turn off. As soon as you accelerate, and when the system feels a different pressure from the different altitude. Post-operation after landing, the Wi-Fi will automatically turn on due to the same pressure of when landing and with it feeling no acceleration and being sat still. You can then make use of the web interface again to check any mission logs, and with the automatic feature on the Minivux, it will automatically shut itself down upon landing, so no need to boot it down after landing, as it will automatically do that for you. Finally, you'll take the memory card out of the scanner and you'll start processing. With this, RIEGL isn't just a LiDAR manufacturer, we're a systems and solutions provider. As we collaborate with many of these UAV companies, we continue to produce various integrations that are good for everybody's use. Here's a few integrations we've done with our UAV platform affiliates. With the help of these affiliates, we've been able to produce very sound and secure integrations that allow for a turnkey system for the end customer. For example, we have anything from a heavy lift system to lift our 840 GL with the Shriver and Harris Aerial's H6HL, gas hybrid platform options for those long duration missions, and even small electric UAVs for small missions in urban areas. With all these UAV manufacturers, our newest integration is with the Strike Air carrier with the VUX 1 2023 edition. This fixed wing aircraft allows for 3 to 4 times faster data acquisition than multicopters, featuring a 4 to 7 kilogram payload and a flight time of 1 to 1.5 hours. We've also like to introduce our new DJI M300 kit. This kit is the same as the M300 kit that we had before, with the introduction of the M350 and the stopping of production of the M300. This allows for users to continue to use the new DJI M350 for systems like the Minivux 1 UAV, the Minivux 3 UAV with RIEGL, or the Minivux 1 UAV and 3 UAV with the APX-15. This kit comes with mounting plates, shock absorbers, antennas, cables, and even an instruction manual to help with integration. It's extremely fast and easy integration and a fully automated operation, allowing RIEGL to run and no action needed during operations such as a PWM switch. Here's a high-level representation of the integration we've done for approval and non-approval. For example, in the red box are the RIEGL USA affiliates that I myself work with here at RIEGL USA, such as Harris Aerial, Watts Innovations, FreeFly, Skyfront, Inspired Flight. Here it shows many of the payloads that we have tested, integrated thoroughly, and showing some of the compatibility, with the green check mark showing systems that are approved, the red X showing systems that are not approved, and yellow meaning we need further info. For example, with the Ace Core NOAA, the Shriver S100, and the Harris Aerial H6HL, through testing, we have shown that it can carry the VQ840GL with ease. Some more of our upcoming webinars are actually start tomorrow with 10 new wins, innovations and updates in terrestrial laser scanning from 11 a.m. to 11:30 a.m. Eastern Standard Time. Value and efficiency with Joshua France on October 17th at 11 a.m. Eastern Standard Time. New RIEGL innovations and updates in airborne laser scanning with our airborne division manager at RIEGL USA, Michael Sitar, happening on October 19th at 11 a.m. as well. And new RIEGL innovations and updates with our Latin American manager, Claudio Avello, on October 19th at 1 p.m. Please follow the QR code, follow the updates with all of our division managers, and updates from Intergeo. From here, if anybody does have any questions about anything from the presentation, please type them in the question box. From Matt, you mentioned that the scanners are good for multi-rotor or fixed wing UAVs. Which of these scanners would you recommend for either option? Great question, Matt. Thank you. For multi-rotor options, all these scanners will fly extremely well. You just may get a higher density with some of these scanners that may have been built for fixed wing UAVs. For your fixed-wing UAVs, I would suggest anything from the VUX-1 2023, the VUX-1 60 23, and the VUX-1 80 24 edition. All these scanners are built for fixed-wing aircraft and high-speed collection, and can even be used on aircraft as well. For any fixed-wing, I would suggest those scanners. For any multi-rotors, any of the scanners would work extremely well. Great question. Thank you, Matt. Another question. When will RIEGL be available? As of right now, RIEGL should be available next year around the beginning of Q2. How much will the new industrial camera drop in weight? Overall, the new industrial camera should drop something around a kilogram of weight off of the entire system payload weight. This is going to allow for longer flight times, given that 1 kilogram will give a lot more flight time and flexibility for your UAV. I think that's about all the time I have for today. I'd like to thank everybody for joining me today to discuss the new RIEGL ULS updates from Intergeo this year. Thank you for the great questions. Anything that wasn't answered, I will gladly email you and answer your questions. If you happen to have any questions about the presentation whatsoever, please email me at tshriver@rieglusa.com. Please don't hesitate to reach out. I'd be glad and happy to answer any questions you may have. Again, thank you very much for joining me today, and have a good one.